we're doing solving systems, and we're doing the substitution method. So we did graphing, and we talked about when graphing, we have two lines. If they cross, it's one solution. If they're parallel, it's no solutions. And if it's the exact same line, it's infinitely many solutions. So this is another method that you can do if you don't want to graph or if you don't want to put it into the calculator. Substitution method is best when one equation has an isolated variable. So that means that one equation has either the x by itself or the y by itself. If those are the two variables that you're using, if you're using other variables, then whichever variable is by itself, it is best to use the substitution method. So when using this method, let me zoom in some. First, you're going to identify the equation with the isolated variable. Okay? If there isn't one, you can always solve one of the equations for a specific variable, but if you're doing that, you might as well just solve for y and plug it into your calculator to get what the answer would be. Step 2, you're going to substitute the expression. Substitute the expression equal to the isolated variable into the other equation. And so it's going to take a process of substitution. And you've done substitution before. The way you've done substitution is just a simple take a number and plug in for that specific variable. But now instead of a number, we're going to have an actual expression. And instead of the variable, we're going to plug in an expression where that, where that variable goes. And you'll see what that looks like. So once you substitute, you're then going to simplify and solve. Pretty much check to see if you can distribute. If you can't distribute, then go on to combine like terms. And then solve for the variable, just like you would do when solving an equation. Okay. Step 4. Substitute that value into an original equation. A good tip is to just substitute it back into the one with the isolated variable. Now you're going to solve for the other variable. then step 6, write it as an ordered pair. Okay. So let's move on to a couple examples so you see and get a gist of how to do it correctly. I want to get a different color. And do our examples in black. So example 1. You have the system y equals 2x minus 1, and then 3x plus 2y equals 26, sorry. So notice in this system, the isolated variable is y. So step 1 was find the isolated variable. So that's the equation with the isolated variable. Maybe it'll focus here for you in a little bit. Focus. So step 2 is to substitute that expression into the other equation. So I'm going to take this and I'm going to substitute in for y right here. So that's 3x plus 2, and now instead of y, I'm taking this stuff right here, 2x minus 1. Equals 26. So that was step 2. We substitute the expression for the variable. In this case, 2x minus 1 for y. Step 3, we're going to solve for x. So we're going to simplify and solve. I'm trying to see how I want to do this. So I'm going to rewrite it so you can see the steps as we're going. So the first thing we can do here is distribute. So I'm going to start with distributing. So I take that positive 2 and I multiply it with the other positive 2x. So that's positive 4x. Then I take that positive 2 and I multiply it with negative 1. So that's negative 2. I'm going to bring everything else down. Once I distribute, I'm going to combine my like terms. In this case, my like terms are 3x and positive 4x. Remember, to combine, that means to add them. So 3x plus positive 4x is 7x. I'm going to go ahead and drop everything else down. And lastly, now we have a two-step equation. Now, it's been a while since we've done it, but it should come second nature pretty much to most of you from now. So the last thing is I'm going to solve for x. And I do that by adding 2 to both sides to begin with. This 2 is gone, so it cancels out to 0. 26 plus 2 is 28. And I bring everything else down. And then I divide by 7. 7 divided by 7 is 1, which is irrelevant. So we have x equals 28 divided by 7 is 4. Now that's only half of the answer. If you recall, a solution is an ordered pair. An ordered pair needs an x and a y. So step 4, we're going to substitute the value back into an equation. Again, I suggest doing the one that's already isolated. So I'm going to substitute 4 for x in y equals 2x minus 1. I'm going to use a different highlighter this time. So x is 4. So in my equation, y equals 2x minus 1. Instead of the x here, I'm going to put a 4. That's going to be y equals 2. That's where the 4 is going to go. Minus 1. Step 5 is to solve. So 2 times 4 is 8. Bring down the minus 1. I'm writing tiny because I don't want to run out of space. And then 8 minus 1, y equals 7. So now I have my y. And I have my x. So step 6 is write the ordered pair. So in this case, it would be 4, 7. Okay. I'm going to do one more. Same idea. Just see it one more time. So negative 4x plus 3y equals negative 14. And then my other equation is x equals negative 3y plus 26. I'm just going to talk my way through this one instead of writing the steps on the side, just so you can see how you would normally do it without having to write the steps each time. So the first thing is to look for the equation with the isolated variable. And here we go. The x is isolated here, which means this is the expression I'll be substituting into my other equation. So where I see the x up here, I'll be putting negative 3y plus 26. So that's negative 4 parentheses. Here's where I'm going to write the negative 3y plus 26. Close your parentheses. Everything else is still there. Plus 3y equals negative 14. This one didn't get highlighted. Okay. So step 2, sorry, that is step 2. Step 3 is to simplify and solve. So now we got to solve this one for y. So I'm going to start by distributing the negative 4. Negative 4 times negative 3y is positive 12y. Negative 4 times positive 26 is negative 104. I just know that because I have it from last year. But use the calculator if you don't. And I drop down everything else. Continue solving this. We combine my like terms. 12y, positive 3y. Combine means to add, so when I add those, I get 15y. And I drop everything else. Minus 104 equals negative 14. We're solving for y, so I got to get rid of this by adding 104 to both sides. This is gone, canceled, 0. Negative 14 plus 104 is 90. And last, I'm going to divide by 15 on both sides. That's a 1, irrelevant, so y equals 6. That's just part of my answer. Remember, I have to find the other part by now taking this and substituting back in. So now I'm steps 4, 5, 6. So now I have what my y equals. My y equals 6. So back in my original equation, and I like to use the one with the isolated variable. It just makes my job easier. Where I see the y is where I'm going to be putting that 6. So x equals negative 3. Again, this is where 6 is going to go, plus 26. And we solve. Negative 3 times 6 is negative 18, plus 26. X equals 8. So now we have x equals 8, y equals 6. So my solution is 8, 6. Okay. Once you're done, come see me, find yourself a partner, and you're working on the next part, which is creating chains on a separate sheet of paper. Ooh, that red's not very nice. You're going to be doing each problem showing these steps. Showing just like I did it here. I need to see this working. You're going to turn this in. Once you get it, you're going to write the solution right here. And this chain, whatever your solution is here, should link up to the next one that has that exact same solution. I suggest finding all the solutions first, then connecting them to make your chains. If you have any questions, let me know.